Hello, everybody. Welcome. Good morning. This is Ilam. I'm a product manager here at Couchbase. And as Franco mentioned, I previously have experience working with some database technologies as well as the big data. I'm very excited to do this webinar. And our topic is scale your application globally using Couchbase and XDCR. XDCR is a term we use here that stands for cross data center replication. So let's get started. So at the outset, I apologize for the slide. I think the title just got a little messed up. But Couchbase is an open source project. We are a leading NoSQL project focusing on the distributed database technology. We are both a key value and a document-oriented database, and that's important to note that we provide the advantage of the key value, but also you have the facility of document-oriented databases. We are under the Apache 2.0 public license, and it's just wanted to make sure that people understand and everybody is on the same page as to what the Couchbase project is. At a high level, there are some really strong capabilities that Couchbase provides. One of them is scalability. As you might have experienced with relational database systems, it is really hard to scale out a relational database. You could do it to some extent, but there's a lot of trade-offs involved in that. And one of the main goals for Couchbase is we want to be able to grow the cluster without requiring application changes and without needing downtimes and things like that. Also, Couchbase is renowned for providing consistently high performance, and there are customers who have requirements which are sub-milliseconds in terms of read and write response times, and they need it to be met consistently, and they've successfully used Couchbase to achieve their goals. We also provide always-on capability. In the era that we live in, there's really not much of a downtime or a maintenance window that people have. It's especially when you're online, people need the software and applications available all the time. Upgrades have to be done without downtime. Maintenance has to be done without taking the application offline. So Couchbase, from its design perspective, always handles this in its product. Key advantage in a NoSQL system is the flexible data model. And Couchbase, being a document-oriented database, we have the JSON document model. And that provides advantages in terms of, if you're using an RDBMS, you would know how hard it is to make a schema change. You have to go to the administrator. It could involve downtime. It's a long process. It's a little painful as well. But the reality of the situation is that data models evolve, and that's the nature of applications. And by providing a flexible data model, it's really advantageous to have lower cost in terms of development, lower cost in terms of being able to maintain your applications. Before I drill down into the specific feature for our webinar today, I just wanted to share with you a high-level additional features that Couchbase Server provides. We provide built-in clustering where all nodes are equal, so you don't have a special node. Like I come from a Hadoop background earlier, and Hadoop has this name node, which is sort of like a golden node, and it can go down. It could be a single point of failure. There is no such single point of failure in Couchbase. All nodes are equal, so if failure happens, we will just handle it gracefully. There is data replication with automatic failover possible. Manual failover is also possible. And like I mentioned, we have zero downtime for maintenance. And we also have a built-in managed cache. Couchbase, the founding part of Couchbase also included Membase, which is an excellent built-in Memcached-based product. And so Couchbase really has the cache built into it. Unlike some other databases where you would have to have a separate solution for caching, here we actually have the cache built into the product, so that's a big advantage. And it's also, Couchbase is an append-only model, and what we mean by that is any of your writes have in an append-only format. The reason for that is to provide really, really high write rates, and we would later on compact things and handle it, but your operations are not blocked, so it's really fast. We have online compaction that has been introduced, where you don't have any downtime for that. Compaction happens as your system is online. Couchbase also provides a good set of monitoring and admin APIs and user interfaces, where you can actually take a look at your health of the server, the various statistics, various parameters in the server, and know what's going on. It'll help with troubleshooting, logging, things like that. Also, we provide SDKs for a variety of languages. We have like Python, C language, Java, .NET, and a bunch of other things that we always keep improving that. And there are a few community-based ones as well. And these really help your application development on the client side, especially to interact with the server. I just wanted to give a brief overview in case some people are not as familiar with Couchbase. The Couchbase node looks like this. We have a data manager and a cluster manager in every node. The data manager handles things like the storage. It also handles the object managed cache. And there's also a query engine where you could use the query engine to query data which is persistent. As well as there's a cluster manager. And the cluster manager is responsible for the REST management APIs, as well as for things like replication, rebalance, and managing shards and states like that inside the cluster. So that's what the thing is. And every node in the Couchbase server has a data manager as well as a cluster manager. Couchbase data uses a consistent hash partitioning. So we provide for a fairly uniform distribution of data across the nodes in a Couchbase cluster, and as well as it provides for the reason why it's consistent is that the data is mapped into vbuckets, and the mapping is fairly consistent, which vbucket is mapped to. Now, vbuckets are nothing but virtual partitions that we have in Couchbase for managing things, and it's a unit of data that can be replicated as well as assigned to different nodes in the Couchbase server. And when you have data, we know which vbucket it resides in, and there's a cluster map which actually manages the mapping between a vbucket to a physical node, and that's how we determine where the data is residing. Just a quick update on the basic operation in Couchbase. So as you can see here, the documents are distributed evenly across the servers. If you have 3 servers, you find that the documents are distributed across them. And there's a set of active documents. There's also a set of replica documents. And each server stores both active and replica documents. So for example, in this case, if you have a document 9, which is active on server 1, you find the replica of it on server 3. And similarly for other documents, they are spread out. So you have both the active as well as the replicas distributed across your cluster. And the client libraries provide applications with a simple interface to the database. There is a cluster map. The cluster map provides information on which server a document is residing on. And the app doesn't really need to know that. It basically can use the smart library, smart clients to find this information, and it sends the reads, writes accordingly. Now, as you can see here, the reads and writes will be distributed across the system because we're actually distributing the data itself. All right, now we come on to the XDCR, which is the cross data center replication. And we use the term cross data center replication quite a bit, But an accurate way to describe what this is basically it's replication between Couchbase clusters. Where the clusters can be located is wherever you would like. They could be within a single data center as well. They could be at your home office, or they could be at a geographically different location across continents. It could be in Europe. It could be in Asia Pac, right? So it allows for different possible configurations. Here, and the reason we said globally is because here we have an example where you have a US data center, you have a Europe data center, and an Asia data center, and you have clusters replicating data across these different data centers. And as you would see when I go through the presentation, there would be different topologies that are possible and things like that. But the reason I mentioned its replication between clusters is that there are other use cases where it need not be across data centers, it need not be across geographies, but it can be within the same data center for dev, for test, for things like that. So essentially, it's a feature that provides replication across clusters. And there's a lot of interesting things you can do with this Couchbase, and the replication provides additional interesting things you could do as well, as we would see later on in some of the use cases. Wanted to go a little bit over the basics of the cross data center replication. So you can replicate your Couchbase data across the clusters. It may be spread across geos, not necessarily, but that's one possibility. And the configuration of the replication is granular. What I mean by that is there is the notion of buckets in a Couchbase cluster. What is a bucket? A bucket is basically a logical partition of data within a Couchbase cluster. If you're familiar with relational databases, it's maybe roughly thought of like a database within a server. You could have multiple databases. So roughly you could think of it that way. I wouldn't exactly term it as a database, but it's a logical partition is what we would call it. And there can be more than one bucket in a cluster, and not every bucket needs to be configured for replication. So you can choose to configure replication at a bucket level. So it's pretty granular. One bucket may be more important, critical for you, and so you could make those choices. We also support unidirectional as well as bidirectional replication. What it means is that you could have data being replicated from a cluster 1 to a cluster 2 in one direction. You could also set up a replication from your cluster 2 to the cluster 1. Why would you need something like that? Well, it's because your application can read and write from both clusters. We do support active configuration as well. There is a master slave if you want just hot standby, but you could also do a master-master type replication, in which case you have bidirectional stream set up. A very important point to be noted is that replication throughput scales out linearly. Just like your within a cluster, we provide scale out feature. Even for replication between clusters, we provide scaling out linearly. So what it means is that if you have more nodes that you add to the clusters on either side, we would take advantage of it to be able to scale the replication between the clusters. So it is able to scale when it provides more resources to the cluster. And this is different from intra-cluster replication, and I will go over it a little more detail in the following slides. But keep in mind that there is replication that happens within a cluster as well, which is called the intra-cluster replication. That's more for high availability. And there's also replication between clusters, which is what XDCR is supposed to do. So I was just talking about this intra-cluster replication. So you have active data on every node within your cluster, and this is a single cluster. But you also have replicas on each of those nodes. And what it means is that if, for example, node 1 goes down, you have replica of the data in node 1 in node 2 as well as on node 3. You can configure it in different ways, and therefore your application is not down, you still have availability. So essentially that is intra-cluster replication, and it's done for high availability even if a node goes down within the cluster. As opposed to that, we have cross-data center replication, which is XDCR. Here you have, for example, a data center 1 having a cluster and a data center 2 which has another cluster. And there is still intra-cluster replication going on. You can see that within the nodes of data center 1 there's replication. Within the nodes of data center 2 there is still intra-cluster replication. But we also have replication going on between the data centers. And in this case, we have represented it with a bidirectional XDCR for between data center 1 to 2 as well as 2 to 1. And you have applications which are reading and writing data to data center 1 as well as to data center 2. And this is one of the topologies that is possible in XDCR, and it also illustrates the XDCR versus intra-cluster replication. Any questions so far?
Yeah, we have a few questions. Maybe we can answer a couple now, and then we keep going with the presentation. So a question is, can I replicate a set of documents from a bucket instead of the entire bucket?
This is the so the answer is today it is not possible. This is what we call as a filtered replication, filtered XDCR. This is something that people have requested us. It is something that we are seriously considering, and in fact, I think there are plans to come out with filtered XDCR in a future release. We are still working on the designs right now, but the answer is not today, but will certainly be there in the future, where you can actually filter only certain types of documents and things like that to replicate. So yes, it will be available in the future.
Thank you, Ilham. And we have another question. I don't know if it's you, Ilham, or Anil can answer. So are the reads and writes done from the same node in the replica set? Can we do reads from one of the slave nodes and write to the master node and allow replication to sync the data? This might require some clarification.
So this is Anil Kumar. So by design, Couchbase, we don't allow the reading from the replica set. It's optional. I mean, we have replica APIs to read from the replica set, but by design, we are strongly consistent. So all we read and write has to go to the active partition.
Thank you, Anil. So please keep sending questions using the chat box. Again, we are collecting all of them, and then we will answer more questions at the end of the session.
Okay, let's go on with the presentation. So in a single node Couchbase, let's see what happens when a write comes in, and what happens, how does it get to the XDCR. So you have the application server, which is connected to the Couchbase server, and here we are showing one node in a cluster. There is a document 1 that gets generated on the application side, so let's say the document comes in to the server, it goes to the managed cache. So that's where the document first gets there. That's the memory, and then we also have a replication queue, which is the intra-cluster replication. Now, keep in mind that the document is not yet written to the disk. So what happens is the document first gets into the replication queue as well as to the disk queue. Once it gets to the replication queue, it can go on to other nodes within the cluster. So that's the intra-cluster replication. However, this document doesn't yet go into the XDCR because it's still waiting in the disk queue. Now, at some point in time, doesn't take too long, but the disk queue will get flushed and the document goes into the disk. And once the document goes into the disk, now it's available for the XDCR engine to pick it up and send it across the wire to a different cluster for XDCR. So I'll just make sure I repeat this again. So the app server sends the document, it goes to the managed cache, goes into the replication queue for the intra-cluster replication, goes into the disk queue. When the disk queue is flushed, it goes into the disk, and then it's picked up from the disk by the XDCR engine, and then sent on the wire to the other cluster. So that's the operation flow. I just wanted to illustrate that. So it's a little more detailed. We're just showing the same thing, but in an internal flow. So here we have the first step, the doc gets written to the managed cache. Number 2, it gets added to the intra-cluster replication queue and also to the disk queue. And then number 4, XDCR will push the replication to the other clusters. Keep in mind here that XDCR is a push model, so the data gets pushed from the source to the destination clusters. So it's a push model that happens here. So let's see the XDCR in action. So here, let's say there's a Couchbase Server cluster in New York. So this is a New York center, and there are 3 servers, and you have documents, and they're in disk. And let's see what happens when you have a Couchbase Server cluster in San Francisco. So you have the East Coast cluster, and now you have a West Coast cluster. And let's say we set up XDCR from New York to San Francisco, and now what happens is the documents from the disk, they are sent to, it's a neat animation, but sent from the New York to the San Francisco data centers. It gets into the cache in the San Francisco data center, and then will be persisted onto disk in the remote data center as well. So let's take a look at the XDCR architecture now. As I mentioned, you have a cluster 1 and a cluster 2, and the replication is configured at a bucket level. So here we illustrate that for bucket A, there is no replication that is taking place. For bucket B, we have a unidirectional replication from cluster 1 to cluster 2. For bucket C, we have a bidirectional replication, so the data is replicated from either side. And the bidirectional replication is basically set up as 2 unidirectional streams. So you have a unidirectional stream from cluster 1 to cluster 2, and you set up a separate unidirectional stream from cluster 2 to cluster 1. And that's basically how bidirectional gets set up. And XDCR, it's important to note, is continuous replication. So it's a continuous, reliable replication that happens. All data mutations are replicated to the destination cluster, and this includes things like deletes as well. So any of the writes, deletes, updates, they get replicated to the destination cluster. And multiple streams are used to round robin across the V buckets in parallel. By default, we have 32 streams. That number can be changed depending on the hardware that you have. If you have really powerful hardware and machines, you could up this number of streams to do XDCR faster as well. It is also important to note that while we send data mutations, we also do deduplication. So if, let's say, what it means is, so let's say there are 3 updates to a document, only the latest update will be persisted to the disk. And so we are efficient in terms of just sending the latest update to the other side. Also, we have checkpointing in XDCR. So because we're able to do checkpointing, let's say if there is a network disruption that happens now, and let's say the network comes back up, we automatically resume the XDCR after the network disruption. We don't have to send everything we do know that what was received in the destination side, so we can resume where we left off and continue the replication. So in that sense, it does provide a good, continuous, reliable replication feature for Couchbase. And XDCR is also cluster topology aware. The number of nodes on your source and destination can be a little different. So you could, for some reason, have 8 nodes on your source, but only 6 nodes on your destination side. And XDCR can handle that. It's aware of the topology. Also, when you have a node that fails, let's say on the source side, or if there's an addition of nodes, XDCR can automatically handle these situations of node additions and removals, and XDCR replication still continues fine. So it's important to note that we are cluster topology aware, so that's not a problem for us. We handle it. And also XDCR is quite efficient in how we operate. As I mentioned, we do deduplicate the write to disk. When multiple updates happen to the same document, only the latest version is stored to the disk. And that ensures that only the last change gets passed on to XDCR, so we are not doing additional work which is not required. And the document revisions are compared between the clusters prior to the transfer, so it's something that we would handle it as well. What happens when there's conflicts? I'm sure this is a question that you have. So when you have active-active clustering, you could have conflicts that happen. And Couchbase provides strong consistency at a document level within a cluster. But across clusters, if you try to do strong consistency, that will be too much of an overhead. So what we provide is eventual consistency across the clusters. So if a document has changes that happens on both the clusters, then we make sure both clusters will pick the same winner. So there's no inconsistency. Eventually, both clusters will be consistent and will have the same version of the documents. So in case of a conflict, excuse me, in case of a conflict, there is a conflict resolution that we would do. And the document with the most update will be considered the winner. So for example, in this case, if there's a doc1 on DCE1 where you have an update, and let's say there are 3 updates that happen on the data center 2, then that latest will be considered as the winner on both the sides. You could have a question, what if there are the same number of updates on both sides? Then we have conflict resolution based on revision, on CAS values, on sequence, things like that. And that's what we have today for conflict resolution. But the important point to note is we will pick a winner, and the winner will be the same on both sides. So you will not have inconsistency. You will have eventually consistent representation on both your clusters. Let's look a little bit at the configuration and monitoring for XDCR. What are the key advantages of XDCR in Couchbase as compared to other NoSQL products or other database products, for example, is we make replication setup really, really easy. It's a 2-step process to configure replication between clusters. And once we go through this, if the demo gods permit, we'll hopefully be able to show you a successful quick demo on how to set it up. But it's really simple. The key point I want to drive is while there is a lot of complexity and technology involved in terms of cross data center replication, and our engineering teams have worked really hard to make sure it's an efficient process, and we really do a great job at that. In terms of the customer interface, we wanted to keep it really, really simple. So we have a 2-step process to set up replication, and I think it's one of the key advantages for Couchbase compared to some other products in the industry where we have strived to make it really simple for users to set it up and monitor and things like that. So the first step is to define your remote cluster. So what we mean by that is to create a reference to your remote cluster. So you put in a cluster name, you put in your IP address and your authentication, and it sets up a remote reference. Very simple, just 4 fields, as simple as that. And the next step, you create a replication. So you say that you create a replication from your current cluster You pick a bucket and you say, well, I want to replicate it to my west coast, and here's the bucket to which I want to replicate. You make sure you create a bucket on the other cluster, and you can put it in here. And you say replicate. That's it. That's about as it is. It just sets up the replication, and it starts the replication stream. So, and it's easy to monitor the ongoing replication. You have an XDCR tab in your administration UI, and you can look at the ongoing replications, and you can create your references here, replication streams here, monitor them. And you have information on different parameters and statistics that you can look at in terms of what's your XDCR queue, how many operations are happening, and things like that. And I'll show this to you in the demo, so you'll actually see a better latest version picture of this. So before I start the demo, if there's any questions I could answer, and then we could do a quick demo to just see the scenario in action.
Yes. Again, we have a lot of questions. We will try to answer as many as we can. For those that we're not able to answer, we will follow up after the webinar. So, is there an auto merge option in case of a conflict? Auto merge option in case of a conflict.
Auto merge?
Yes.
Okay. Basically, there is no merge. We pick a winner. So we will pick one of them as the winner based on our algorithms, and that would be the winner on both the sides. So we do not merge it.
Yes. So
yeah, we have another question about the conflict resolution that maybe you want to give more details about it.
Sure. So again, this is Anil. So as Ilham mentioned, currently the conflict resolution is handled by an algorithm. So based on the algorithm, we check the revision ID, sequence number, cache value, and a bunch of stuff to pick the winner on the either side. So in the later future releases, we are planning to build a plugin mechanism where we give the access to the user to specify which key what needs to be checked for conflict resolution. So that's not right now. We don't have it right now, but it will be included in the future releases.
Thank you.
Thank you, Neil. So yeah, again, a lot of questions about the conflict that you just answered. So you showed about that replica that becomes active. Can you talk about more when the replica becomes active in Couchbase and in which kind of scenario that happens?
Sure. So, for example, when you have like a failure of a node, and then we want to promote replica from another node to the active. So when a failure, manual failover that you can kick in, and when you kick it in, it immediately becomes active. Actually, replica becoming active is just a metadata operation, so it's really, really fast. So it happens very quickly. Or if you have an auto failover, similarly, because when you detect a node is down and you remove it from the cluster, you will promote the replica to active, and now your application continues to function normally because the data is still available. So.
Thanks, Ilham. And a question about scalability, and again, on the cross data center replication part, if you add a node to the first cluster that replicate to the second cluster, do you have to add the node to the second cluster as well?
Yeah. So the answer is no, because Couchbase supports configuration where you could have, let's say, 8 nodes in your source cluster and maybe only 6 nodes in your destination cluster. So we would be able to handle a different number of nodes from the source as well as the destination. So the answer is no. If you add a node to your source cluster, you don't necessarily need to add a node to the destination cluster. However, I would like to add that XDCR does scale linearly. So if you add more nodes to the source, and if you add more nodes to your destination as well, we would take advantage of it. We would be able to do a higher performance in your XDCR and things like that. So if you provide us the resources, we will take advantage of it. We will not make it mandatory though.
Thank you. Is there a minimum number of nodes in Couchbase for a Couchbase cluster?
Yeah, we usually recommend at least 3 to 4 nodes for a cluster, right?
Yeah.
So ideally, I would answer that there's so the max limit would be like we have a the number of V buckets, the partitions we create internally is 1024. So actually, there's no limit unless until you hit 1024 servers.
No, it's more on the minimum number.
He was asking the minimum.
Yeah. So there's no minimum number. You can have a cluster with 2 nodes, but if you have less than 3 nodes, you're not able to take advantage of our replication features. So if you have 2 nodes and 1 node fails, then you're left with a single point of failure in your cluster. So if you have a cluster in production, you definitely want to avoid that situation.
I would say in terms of key value performance and things like that, we've seen 3 is a good minimum to go. That's what we recommend usually.
Anything less than 3 nodes, again, you're looking at that situation. So if you have 3 nodes, 1 node fails, you know that you're still your cluster still has the replication and is still active. Okay, so a question about performance. What happens if we are using Memcached and we want to switch to Couchbase? Is there an advantage in doing that?
Yes, definitely. So to answer that question better, the Couchbase. So in Couchbase, you can create 2 buckets, 2 types of buckets. The one is Memcached bucket and the Couchbase bucket. The Memcached bucket is just the in-memory part of it, and you don't get the persistence. But if you create the Couchbase bucket, you get both the in-memory as well as the persistence. So it's kind of layer consolidation. So you get the best of both worlds. You get the in-memory as well as persistence.
Yeah. Also, you get advantage of things like replication, XDCR, things like that. So we provide a lot more advantage in terms of that. So there is significant, I would say, there is significant advantage in going to Couchbase from Memcached. In fact, many of our customers were Memcached people who have taken advantage of Couchbase and have taken advantage of other features as well later. So it's one of the most common scenarios we see. So.
Perfect. Thank you, Ilham. Let's do the demo now, and then please keep sending questions. We will have probably another few minutes at the end, and we will respond as many as possible.
All right. So, are you able to see my screen?
Yes.
You are able to see the screen. Okay. So we have. I just want to show move along the demo a little faster, and for the sake of time. But we have a 6-node Couchbase cluster, and this is in right scale. We've set it up, and a 4-node cluster for the XDCR on the destination side. And let me just actually get started. I will. So I take the IP address, and I can get into the management console. We log into the Couchbase. So you see here there are 4 nodes in my cluster, and I also have, if I go to the data buckets, I see that there is a beer sample data buckets, and there's 7,303 items in this data bucket. So let me go to the destination cluster as well. So I log into the destination cluster. So if you see here, there are 4 nodes here as well. And if you go to data buckets, there is a beer backup data bucket, and you'll see there are 0 items. So there's no data in this bucket here.
Ilham, we have a little bit of a lagging, so if you can just move slowly so we can see. Because to go to webinar is lagging a little bit.
I see. Okay, no problem. Okay, so just to show again, this is the source cluster. It has 7,300 items in the bucket, and okay, now I'm in the destination cluster. There's a beer backup, and there is 0 items in it, so I just wanted to show that. And if I go to server nodes, I see there are 4 nodes in my cluster. Okay, now it shows up. Fine. All right. So let me go back to the source, and I want to set up XDCR. So what I do here is now I go into this tab here for XDCR. So I click on XDCR. Okay. So let's first create a cluster reference. So let's go to create cluster reference. I can put a cluster name. I can say, let's say, San Francisco data center, for example. And then the IP host name. I think I just have that. Okay. I put in the password. Make sure I put the right IP. Okay, 54. Okay. All right, and just hit save. And as you can see here, now it's created a remote cluster reference, right? And that's about it. And all we need to do now is to create the replication stream, right? So we can go to create replication, and I can choose this cluster. I can say beer sample bucket. And I am going to choose the remote cluster. So I'll choose the SF data center, and I will say the bucket name beer underscore backup. Okay, and then I'll say replicate. Okay, so now I have created the replication, and if I go to the cluster, where did I get the monitoring in XDCR? Data buckets, and if I click the data buckets here, if I go to outbound XDCR operations, you can see that data is actually being transferred. You can see the XDCR queues, you can see the data replicated, operations, and things like that. And if I go to the destination, and if you see the data buckets, you see previously it was 0 here, and now you see the count is 7,303. I'll just wait for a couple of seconds for the screen to be refreshed. I think the webinar screen is taking a little longer. Okay, so now we are in the screen for the destination, and you can see the item count is 7,303, and that is because we have been the data has been replicated from the source to the destination, and that's why you see the item count here. And if I click the data bucket, and I can go to the incoming XDCR operation, and it doesn't show it right now, but if I, for example, change to hour, so let's see in the last 1 hour, you'll see here that there is operations that have happened here in the incoming XDCR, which is the reason why the data moved from cluster 1 to the cluster 2. I have a few minutes. Let me show you the bidirectional XDCR setup. So, so if I go to XDCR tab on the destination, I can create a cluster reference. Okay. Yeah, so now I'm in the XDCR tab in the destination, and I'll say create cluster reference, and let's say now we say the New York data center. Okay, and let me get the IP address. Okay, so now we have the information entered here, authenticated. Let's save it, and to create the cluster reference. And then creating a replication is similar. You say create replication, and this time we will choose the beer backup bucket, which is on this node, and we'll pick the remote cluster to New York, and we will say beer sample as the bucket to replicate it to. One thing I want to quickly show here, we have this thing called advanced settings. So it's important to note here that the XDCR protocol that we're using here is version 2. And this is what I mentioned earlier. In the latest release of Couchbase in 2.2, we have optimized the XDCR protocol to base it on XMM. What basically you can think of it as version 2 of XDCR protocol. It provides for higher performance. It is better in terms of resource utilization, on CPU utilization, and things like that. So if you have the latest Couchbase on both your clusters, we strongly recommend leaving the default, which is version 2 here. It's much better in terms of performance as well as resource utilization. However, if one of your clusters is on the older Couchbase version release, then you will probably have to choose version 1 of our protocol, and through this list you can choose that. You also have some other advanced settings here. For example, failure retry interval, by default it is 30 seconds. You could change it, and this is basically if there is a network disruption or something like that, how often will it try for if there's a failure. You also have XDCR optimistic replication threshold. What it is we have optimistic XDCR now, where we don't have to always check metadata on the destination side before sending a document. If the document is less than 256 bytes, for example, we would just send it because it's faster to just send it than to check. You can change it to a different interval threshold if you want for XDCR. So I'll leave the settings at the basic. I'll just say replicate. And you could, for example, now see that if you go to the outbound XDCR, we actually have outbound happening. Previously, there was nothing here because we never had any outbound from here. And similarly, if you go to the other cluster, which is our New York, and if you go to the data buckets, and if you see here, now under incoming, we actually have some incoming data that came in from the other side. So this is essentially two unidirectional streams, and it's pretty easy to set up, and now you have a bidirectional setup that happened. So I just wanted to show that as a quick demo. There are obviously other information that you could look at in terms of in our documentation where you could try different things. So let me go back to the presentation now. So let's look at a few XDCR topologies that we could have. So as I mentioned, there's unidirectional. You could use like a hot spare or for disaster recovery, going from one cluster to another cluster. You could also, within the same data center, for example, do development and testing, and some of our customers use it in that manner as well for dev and test mode. And you could have bidirectional, which I just showed you in the demo, in which case you could even do active-active. So you could have workload going on both clusters and doing bidirectional replication. It could also be used for disaster recovery as well as for data center locality. What do you mean by that is you could put data centers closer to where your application users are accessing the data. So you could have, for example, people on the West Coast going to your West Coast data center, people on the East Coast going to that, people in Asia going to data centers closer to Asia. And that provides for data center locality as well. You could also have more complicated topologies. You could chain your replications. So you could have data center 1 doing bidirectional with data center 2, and data center 2 going to data center 3. So you could imagine a more complex scenario where you chain replications across data centers. And data aggregation. We have customers, for example, who are using this sort of a topology. They would have, for example, manufacturing data coming into local offices in different areas, and then data being aggregated from the local offices to a regional office, and then to the main headquarters, and they could have a replication set up between data centers that way. So you have aggregation of data. Now you could also imagine the reverse of this, which is data propagation. You have the main regional offices, and you are sending data from the main regional offices down to your local offices. So you could do that as well. So in that sense, you could have different types of topologies. You could also have XDCR in the cloud. And one thing to information to mention here is today XDCR traffic is not encrypted. So, however, in our roadmap, we have plans to provide for security in XDCR. So we will have encryption in XDCR coming out soon. So it is part of that. But you could have public XDCR as well with Amazon VPN solutions and things like that. And let's look at a quick look at the use cases for XDCR. Scale your data globally. This is very important. So today, a lot of the people have data that they really are, the business and the applications are international in nature. So you want data closer to your users, you want data which is faster. So you could be in US, in Asia, in Europe, and really the Couchbase provides you to have your business global. We support global business in terms of data. Disaster recovery. This is an actual example. You could see here that a customer had different instances, and on April 23rd and April 22nd, the instance in North Virginia went down. But the application is still fine because we have DR available, and Couchbase cluster is still functioning just as fine. So there's no loss of application, no downtime, even if an entire data center goes down. So that's important to note, because a data center going down can happen for various reasons. That could be a disaster where it can happen. So it's always good to be prepared to handle that. This is another common use case for development and testing. A lot of the times the test team needs production data without interrupting the production cluster so they can do testing. So you can give developers local databases with real data so that it's easy for them to develop, easy to build new models, things like that. So you could have XDCR replicating data between a production cluster to a development or a test cluster, so the test and dev teams can use it. It's important to note that your clusters need to be sized for XDCR. XDCR can be CPU intensive, and you configure the number of parallel streams based on your CPU capacity. However, it is very important to note in release 2.2, we have done tremendous improvement in this regard. So I strongly recommend, where possible, use the XDCR version 2 protocol in release 2.2. It provides really high performance and much better optimization of CPU and other resources. But you are using a lot more resources in general, so you would want to size your cluster for that. You need to provide right memory, right set of CPU. And typically the way it would work is, once you are ready to design your clusters, you would engage with our solutions teams to help with this process. A lot more resources can be found on the Couchbase Server manual, as well as we have a blog on XDCR. Please do take a look at these resources, and you can learn a lot more about XDCR using this. Any final questions, answers?
Thank you, Ilham. This was a great presentation. Yes, we have a couple of minutes left, so we have time for a few more questions. So, what parameters can be used to monitor the cluster health, both for XDCR and node?
Okay. So this is Anil. So we have all the monitoring stats which Ilham was showing in the demo. Those are all available as a REST API. Right? So we collect around 120 plus stats, and most of the stats are real time. You can see once you go to the Couchbase cluster, you can take a look at all the stats we've been collecting. So for example, if you set up the XDCR, and on the source cluster, you will see the outgoing XDCR related stats, and on the destination, you will see the incoming XDCR stats. And so you can also use this REST API if you have your own custom reporting tool, for example, the Nagios and those plugins. You can call this REST APIs to plug in the monitoring stats to those particular those reporting tools.
Thank you, Neil. So you said that you talked about sizing the cluster, but is there a recommended memory in gigabyte for XDCR, or it really depends from the cluster?
It really depends. Sizing is a complex exercise. It depends on things like what else is going on in the cluster. There may be views, there may be the number of nodes, your data, the write rates, things like that. So ideally, there is no one recommendation as an overall, but depending on the use case and depending on what happens with the application and the write rates and things like that, we would go through a look at it and say what is the recommended things, and that's where we engage with our solutions team. They're an awesome set of people who can really help people size it right. So.
Thank you, and I think we have time for one last question. Actually, we probably can have two more. So what is the largest chunk of data that can be migrated?
So when we set up a XDCR from one cluster to another cluster, so actually behind the scene what happens is and again, as Ilham explained, it's on a per bucket basis. So on a per bucket basis, when you set up the replication, by default we create 32 replication streams from this cluster to the destination cluster. So this 32 streams are actually the TCP/IP streams, right? So the max data size which can go on the TCP/IP is the 65K, which is again same thing with our Couchbase replication.
Great, thank you, Neil. Another question is, so is there a cluster-wide setting for XDCR, or do we have to replicate bucket by bucket?
So when you set up XDCR, when you set up a reference, it's a cluster-wide. So you set up a cluster reference to your destination, but the actual replication streams are set up on a bucket basis. And the reason we do that, you could have more buckets in your cluster, and some buckets may be high priority where it needs bidirectional, some may just need unidirectional, and some may just not need any replication at all for data center cluster XDCR. So we provide the granularity, which provides a lot of flexibility to our users.
Thank you, Ilham. And one last question is more a clarification. So Brian is saying, is there an option to have the replica not have the replica on the same host as the active, especially for high loops application? So can you clarify more how is the structure in Couchbase cluster for active sets and replicas?
Sure. So we don't actually keep so if you have a node 1, node 2, and node 3, when you have a certain set of documents which are active on node 1, we don't actually keep the same set of the replicas for those documents in node 1. We'll keep it actually in different nodes. And the reason we do that is for high availability. And in the future, we may have other additional things coming, such as rack awareness, for example, where if an entire rack goes down, we still want, and a rack may have more than one node, we still want your data to be available. So we could have topology awareness of racks, where you could have data replicas actually in other racks and not in the same rack. But that's not available today, but it is something that we're working on for the future.
Thanks, Ilham. Yeah, and that is particularly important for large deployment and large enterprises. Okay, I think this is all the time we have for today.
Thank you.
I want to thank you, Ilham and Anil.
Thank you.
And all of you for joining us today. This was actually the last webinar for this year, but in January we will start with a lot more webinars, a lot more educational webinars and online training webinars. So I hope to see you all starting in January. Thank you again.